the equation of a circle is written as x minus h squared plus y minus k squared equals r squared. Where hk is the center, so h is the x value of the center, k is the y value of the center, and r is the radius. Right? Unfortunately, they do not do this formula. You have to memorize it, but it's very similar to kind of point slope a little bit, or the concept similar to point slope. Okay. We can use the Pythagorean theorem to show how to derive the equation of a circle given a center and a radius. So, someone sat down a long time ago, did some math, and discovered how to write the equation of a circle using the Pythagorean theorem. So that's what we're going to do here. So this is a little overwhelming for you. Just go along. I'm not going to ask you to do this on a test. It's just to show you how they came up with this formula, and it might help you understand the equation a little bit better. Okay, so essentially what they did, and I'm going to make this bigger. So what they did is they used the Pythagorean theorem, and what is the Pythagorean theorem again? A squared plus b squared equals c squared. So in other words, it's almost like they're trying to find the distance. They use it to find the distance of the radius. So when we find distance in the coordinate plane, we make a right triangle. Like so. I'm going to orient this board. It's super disorienting. Okay. And when we do the Pythagorean theorem, which one is going to be our c? The hypotenuse. And what's representing our hypotenuse? R. So C is going to be R. Then it doesn't matter. I'm going to make this my A and that my B for the purpose of the formula. Okay. So we have to figure out what our A and our B are, because normally we would just count how many units each side was, but we don't have numbers. They only give us variables that are representing the points. Okay. So remember, when you find distance, so we want to find the distance of this bottom side. You always do big minus small, furthest minus closest. Okay? So we have to figure out, for example, let's pretend, we're just pretending, I'm going to say this is 2, and that x value there is 5. This is just pretend, hypothetical. To find the distance, instead of counting, we would just do 5 minus 2. And 5 minus 2 is what? 3. Okay? Well, we're going to do that with the variables. That was hypothetical. I've made up numbers. So if we take a look at this point, the center, what's it saying that the x value of the center is? Because we're going horizontal like the x-axis, so we're going to look at the x values. What's the x value of this purple point? What is it? H. Right? So now we have to figure out what's the x value of this point. Well, it's in line with this one above here, above it, on the circle. What's the x value of that point? So the x value of this point is also going to be x. So just like we did when we did big minus small, furthest minus the closest, we could say A is equal to what? How we did 5 minus 2, we can say A is equal to x minus h. We did 5 minus 2, we do x minus h. And that would give us the distance. If we knew the number of x and knew the number that represented h, you subtract big minus small. So then we're going to do a similar concept for b. And I'm going to make it a different color that's going to show up a little bit better. We'll go pink. Okay? Just because the colors are very similar to that circle. So now we want to find our b. And we're going up and down, so we're going to look at the y value, same kind of concept. To find distance, you do big minus the small, top minus the bottom. So if we take a look at our 2 points, what's the y value of this cut point? Y. Yeah, y is in that spot. That'll be our y value. Here, for this point, it's in line with the center. And what was the y value of the center? Okay. So same concept, to find distance, we do big minus the small. So our b is going to be what? Minus what? 1 minus k. And then we fill it in the Pythagorean theorem. So our a, we said was x minus h squared. Our b is y minus k, and then we square it, and we said our c was r, and we square it. That's how they came up with this formula. And it's just a general formula. So h and k are always going to be your center. Okay? And then x and y is representing any point on that circle. Okay? And that would give you the radius. Every time. We have a square. Okay? Questions over there? Okay, so that was overwhelming. Don't worry. This was something to show you, to help you have a better understanding. Main thing we need to focus on is what the actual formula is, and that h is the x value of your center, k is the y value of your center, and r is the radius. That's what you need to focus on. Just wanted to show you that, just show you where it came from. Okay. In example 1, it says, what is the standard equation of a circle with center 14, negative 1, and radius 12? Okay, well, I'm going to write down the equation of a circle. Uh-oh, why am I writing one? Yes. X minus h squared plus y minus k squared equals r squared. So this is going to be x something squared plus y something squared equals something squared. We just have to fill in those blanks, similar to what we do with point float. When you get really good at this, you don't have to write the blanks unless you find it helpful. One thing you have to pay attention to, I'm going to flip back. H is representing the x value of the circle, but when it's written in the point, it's positive. What happened to h when you wrote it in the equation? Became what? Negative. K was positive, and when we plugged it in, it also became negative. So just like point slope, when we plug in these values into the equation, we have to change the sign. So this positive 14, because it's the x value of our center, when we put it in with the x, it's going to turn what? Negative. So it's going to become negative 14. This negative 1, when we plug it in, is going to become what? Positive 1. And then our radius, we said, was 12. You have to clean it up at this point. Okay? These stay exactly how they are. That's going to say x minus 14 squared. That's going to say y plus 1 squared. And that's equal to, what's 12 squared? There's our equation of our circle. Once you get better at this and do this more, a lot of students just write this and then they put 144 right away. You can do that, that's fine. You don't have to show that first step. I just like showing the first step. Okay? It's helpful. Questions over that? No? Example 2 says, what is the standard equation of a circle with center negative 7, 5, and diameter 18? Alright, so we know when we write the equation of a circle, x something squared plus y something squared equals something, our radius squared. What happens to our values when we plug them in? The sign changes. So what's going to go in here with the x? Positive 7. Yeah, the x value of center is a negative 7. We plug it in, it turns positive. What's going to go in here with the y? A negative. Because the sign changes. Am I recording? Yes, I am. And then I plug 18 in here, right? This becomes 18 squared? No. Why do I not want to do that? This is what? The diameter. What do we plug in here? It's r squared, and r stands for the radius. What do you remember about the relationship between the diameter and the radius? Flip flop that wording. Radius is half the diameter. So the diameter is 18. What's your radius? 9. You just divide it by 2. Divide your diameter by 2, and that gives you your radius. So we're actually plugging 9 in there. Be careful. Pay attention to that wording. So then this again stays the same. That stays the same, but what's 9 squared? Good, 81. Take a look at example 3. It says determine the center and radius of a circle. X minus 9 squared plus y plus 2 squared equals 49. So we're backwards. We're given the equation. We want to know the parts. So we need to know the center and the radius. Okay. Well, the center, whatever's in the parenthesis with the x is the x value of your center. Whatever's in the parenthesis with the y is the y value of your center. But what happens to the signs? They change, right? Because when we plug them in, so when we plugged in -7 and 5, their signs change. So when we take them back out and write it as the center, their signs have to change back. So here, if it's a -9, when we take it out, it's going to turn what? +9. Here, the 2's negative, so when we take it out, it's going to become a, it's positive. So when we take it out, it's going to be a negative. What do you think we have to do with our radius here with 49 to get our radius? What is it? Square root it. Very good, because in the equation, it's r squared. So to just get r, you take the square root of it. And what's the square root of 49? There's your info. We want our center, we want our radius. Questions over that? The next question is asking, does the point 15, -5 lie on the circle? Okay. To figure this out, all you have to do is take 15 and -5 and plug it in for x and y. The reasoning behind that stems back to how we derive the equation of a circle. Okay? If we plug in any point on the edge of the circle in for x, and any y value on the edge of the circle in for y, it should equal our radius squared based off how we derived it. So if this point lies on this circle, then we should get 49 when we plug it in. If we don't get 49, then it's not on our circle. Okay? So, again, you're taking 15, we're plugging it in for x, and we're taking -5 and plugging it in for y. So when we clean this up, what's 15 minus 9? 6. Plus, what's -5 plus 2? -3. So then when we plug this in your calculator, you have to have parentheses at least around your negative when you square it. What's 6 squared plus -3 squared? 6 squared plus -3 squared is what? 45. Does 45 equal 49? No, they don't equal each other. So does this point lie on that circle? No. It does not. It's just floating somewhere near the circle, but it's not on the circle. Questions over that? Says determine the center and radius of a circle. X minus 8 squared plus y squared equals 100. So again, we need the center and the radius. Well, what's the x value of our center going to be? 8. Good. So -8. Take it out, it's going to become positive. Here's the thing. What's the y value of our center? I don't see a number there. Okay. You're very close with 1. But technically, is anything being added or subtracted to what? What represents nothing in math? 0. So whenever it's just y squared or whatever, it's just x squared, it's just 0. And vice versa. If you're given a point and you want to write the equation, you just write x or y squared depending on which one's 0. Okay? Then what do we have to do with 100 to get our radius? Square root, what's the square root of 100? Questions over that? And you don't have to worry, you don't make the 0 negative, you don't make the 0 positive, because 0 is neither positive or negative, it's just 0. So the next one says, does the point 3 radical 75 lie on that circle? Well, what do we have to do at that point to see if it lies on the circle? What would we do with 3? Plug it in for x. What would we do with radical 75? Plug it in for y. So plug it in. And I know it's a little weird that one of the values is a radical, so that's okay. Clean it up. What's 3 minus 8? 3 minus 8 is negative 5. Right? What happens when we square root? If you're unsure, type it in your calculator. What do we get? 75. Yeah, it's the opposite. So it's like it cancels the radical out and it cancels that out, and we're just left with 75. So whenever you square root, it's like doing the opposite. Just cancels everything out. You're just left with a number that's underneath the radical. Equals 100. Well, what's negative 25 squared? What's negative 5 squared? 25. Oh my goodness. And that's 100. What the heck? There we go. And is 25 plus 75, is that equal to 100? Yes. We have to write 100 equals 100. So yes. This does lie on the circle. Because it was true. 100 equals 100, so that means it has to lie on the circle. Questions over that? Okay. Now we're going to graph circles. We graph them a little bit with dilation, so now we're going to graph it when we're given the equation. So to graph a circle, you have to know the center, and you have to know the radius, or at least be able to figure it out. So we look at this equation. What's our center? What's the x value of our center? Well, if it's negative inside the equation, we take it out, it's going to become positive 2. What's our y value of our center? Negative 4. So what you're going to do is plot that point through negative 4. And then we have to figure out the radius. What do we do again with this number to get the radius? Square root it. And when we square root 36, we get 6. So to graph, if you remember from doing dilations, you just start at the center and you count your radius in all 4 directions. 1, 2, 3, 4, 5, 6. You go right, up, 1, 2, 3, 4, 5, 6. Left, 1, 2, 3, 4, 5, 6. And down, 1, 2, 3, 4, 5, 6. Done. There's that circle graph. If we take a look at example 6, we're going to write equations of the circle's graph below. So we're going backwards. And again, to write the equation of a circle, you have to know the center and you have to know the radius. So they were very nice on this first one. There's this little dot right in the middle. That's representing your center. So what are the coordinates of that center? Negative 5, 6. There's your center. To get your radius, you just start at the center and count outwards in a straight line. So we count how long's our radius? 5. Now we know our center, and now we know our radius. We're going to do exactly what we did on the front. It's going to be x something squared plus y something squared equals something squared. So when we plug in the negative 5, what happens to it? That's 5. Good. And the 6, how are we going to write it in the equation? Minus 6. And then our radius goes here. To clean it up, what's 5 squared? So this becomes 25. We have to square a radius. We write it as 25. There's the equation. You can't leave it as 5 squares. You have to write it as 25. With B, were they nice and gave us what the center was? No. And we have to be able to have the center in order to write the equation. So this is just not possible. Okay? We can use some math to figure out some counting to figure out what our center is. Because if you start, and it doesn't matter where, you kind of have to look at the grid and figure out where am I going right down the middle of the circle. So when I'm basically looking here, this line on that grid is going right through the center of the circle. So the center is somewhere on that line. So cutting the circle in half. And we know the center is directly in the middle. So what we have to do is count all the way across. How far is all the way across? How far? 6. So then I'm going to go back. What's half of 6? There's your center. You count all the way across from one end of the circle to the other. And that's your diameter, going all the way across. Go back, cut that in half. There's your center. Because your center is right in the middle. Okay? So what are the coordinates of our center? 2. Good. And our radius, if you start at the center and count out, what's the length of our radius? 3. So now we can do what we did here. Write our equation. X something squared plus y something squared equals something squared. What's it going to look like when we plug in that 5? It's going to turn what? Negative. Good. That positive 2 is going to turn negative. Oh boy. Negative. And then 3 goes in here. What's 3 squared? 9. So we're going to change that to a 9. You have to simplify it. There's your equation. Questions over that. B, and how to write the equation of a circle without the center is really important for what we're doing on Tuesday. Okay? Being able to do that. You can do that, you can do what we're doing on Tuesday. Okay? Questions? Okay. Here's some practice for this.